In this video, we're going to discuss addition and subtraction of polynomials. We're going to start with addition. When you have two binomials that you want to add to each other, let's look at an example. Let's say we have x squared plus y squared, and we want to add that to x squared plus 3y squared. Since this is addition, we can just drop the parentheses and rewrite this as 4 different monomials and add them like we would add any other monomials. Let's try that. X squared plus y squared, we're going to drop the parentheses, plus x squared plus 3y squared. Now, when we're adding monomials in addition, we can only add if we have the same base and the same exponent. We have an x squared over here and another x squared over here. These two have the same base and the same exponent, so they can be added to each other. That becomes 2x squared. We add the coefficients, keep the base, keep the exponents, add the coefficients. What else do we have? We have a y squared and we have a 3y squared. These two have the same base and the same exponents as well. So we can add these two together, keep the base, keep the exponent, and add the coefficient. Plus 4y squared. And that would be the answer to this question. We added this binomial and this binomial to each other, and we got another binomial. Let's look at another example. Let's say we have x squared plus 2y squared plus z squared plus 3y squared. We're going to rewrite it. We could drop the parentheses and rewrite it as one long string of monomials. In our new long string of monomials, do we have any two terms with the same base and the same exponent that we can add to each other to give us another term? We have an x squared over here. Do we have any more x squared? No. We have a 2y squared. Do we have any more terms that have a base of y and an exponent of 2? Yes, we do. We have 3y squared. So these two can be added to each other. So let's rewrite the question. X squared plus, we can add the 2y squared and the 3y squared to become, we keep the base, keep the exponent, add the coefficients, plus 5y squared. And then the z squared, we only have one z squared, so we can add that. So can't add it to anything else, just keep it how it is. Plus z squared, and this is the answer to the question. Let's look at another example. Let's look at a trinomial plus a polynomial with 4 terms. X squared plus y squared plus z squared plus 9x squared plus 3y squared plus 4z plus b. Let's rewrite this as a long string of monomials because we can just drop the parentheses when we're doing addition. Now we have to see, are there any 2 or more terms that we can add to each other because they have the same base and the same exponent? The first one we're going to look at is x squared. Do we have any more terms that have an x squared? Yes, we do. We have a 9x squared. They have the same, even though they have different coefficients, they have the same base and the same exponent, and they could be added. So 1x squared plus 9x squared is 10x squared. Next, y squared. Do we have any more y squared terms? Yes, we have a 3y squared. So 1y squared plus 3y squared is 4y squared. Keep the base, keep the exponent, and add the coefficients. Next, z squared. Do we have any more z squared terms? We have a 4z that has the same base. It does not have the same exponent, therefore we cannot add them to each other. So plus z squared. Now let's see, what else do we have? Now we have the 4z. Is there any other z term, a z to the 1? There are no more. It stays by itself, plus 4z. And then b is the last one that wasn't added to anything. And therefore, this just becomes plus b, so plus b. And this is the answer to the question, 10x squared plus 4y squared plus z squared plus 4z plus b. Another example. Let's rewrite as a long string of binomials. Now let's see if are there any like terms that we can combine. Like terms means they have the same base and the same exponent. Do we have any more terms that have an x cubed? We do. These are like terms because they have the same base and the same exponent. So all we have to do is add their coefficients. 12 plus 4 is 16. So 16x cubed, keep the base, keep the exponent. Now the next one we want to look at is 3y squared. Do we have any more terms that have a base of y and an exponent of 2? Do we have any like terms? Yes, we do. Keep base, keep the exponent, and add the coefficient. 6 plus 3 is 9, so 9y squared. And then we have one more term, plus z. We can't add that to anything else, so plus z, and that is the answer to the question. Subtraction is a bit more complicated than addition. Let's look at an example. Let's say I have 4x squared minus y minus 3x plus 4. Now we can't just drop parentheses because there's a minus sign between them. A plus, it doesn't matter. But when we have a minus sign, we have to distribute the minus sign over the first term and over the second term also. So let's rewrite our problem how it looks now. The first term stays the same. The first binomial stays the same. But now we distributed this minus sign. So now we have a minus sign going before the first one, and we have a minus sign going before the second monomial. Now we could add it like we add any other set of monomials like this. We just see, are there any with the same base and the same exponent? Are there any like terms? Same base, same exponent. Let's look. 4x squared. A like term would have a base of x and it would have a exponent of 2. Are there any like this? No, there aren't. So this stays how it is. 4x squared. Next, we have a y. This is really y to the 1. Are there any other terms that are y to the 1? Are there any like terms? There aren't, so it stays y. Next, minus 3x. Are there any like terms that have a base of x and an exponent of 1? And there aren't, so it stays 3x. And the last term, there's nothing else that we could add or subtract to it, and it stays 4. Let's look at another example. Let's say I have x squared plus 2y minus x squared plus 6y. Now we have a subtraction sign between the two parentheses. We're subtracting the second binomial from the first binomial. So what do we have to do? We have to distribute the minus sign over the first term and over the second term. So let's rewrite the question. The first binomial stays the same, the second one stays the same. Then we distribute the minus sign over the binomial that's after it. So this becomes minus x squared, and then we have to put a minus before the 6y also. It becomes minus 6y. And let's solve this now. Now all we have to do is combine like terms. Do we have like terms? X squared. Is there a like term for x squared? And there is. X squared minus x squared, they cancel each other out, and we just forget about them. Let's see what else we have. We have 2y. Are there any like terms? A like term would have a base of y and an exponent of 1, and there are. 2y minus 6y, so we keep the base, keep the exponent, so it's y to the 1, or we could just write y, and we do 2 minus 6, we add or subtract the coefficients, so we're subtracting the coefficients. 2 minus 6 is minus 4, and that's the answer to the question. Another example. So here is also a subtraction problem. We're subtracting a trinomial from a binomial. We have a subtraction sign between the two parentheses. We have to distribute the subtraction sign over the trinomial that's after it. Let's rewrite the problem. X squared plus 4y. Now we're distributing this minus sign. So it becomes minus 6x cubed. And we're distributing the minus sign over the minus 7y. So this becomes plus 7y, because it started as a minus, so we're changing it to a plus. And then this one, which started as a plus, we're changing it to a minus. So it becomes minus x. Now we can solve this by combining like terms. Do we have a like term for x squared? We do not. There are no other terms with a base of x and an exponent of 2. Next, we have plus 4y. Do we have any other terms, any other like terms with a base of y and an exponent of 1? And we do. 4y plus 7y, so we keep the base, keep the exponent. 7 plus 4 is 11. So plus 11y. Next, minus 6x cubed. Do we have any other like terms? Do we have any other terms with a base of x and an exponent of 3? Minus 6x cubed. We do not. The only other term we have is minus x. And minus x is not a like term, even though it has the same base, because it has a different exponent. So that's our last term. It stays as it is, minus x. And that's the answer to the question. Now, we probably would want to write this in standard form, because it's just nicer that way. So we want to write it in standard form with the exponents in decreasing order. So first we're going to write minus 6x cubed, then plus x squared, plus 11y, minus x. The order of the 11y and the minus x doesn't matter. This is interchangeable because they both have an exponent of 1. They can't be subtracted because they have different bases, but their order doesn't matter when writing it in standard form.